I will now request Shri Jitendra Kumar Chaudhary ji, Deputy Director, Civil Engineering Department, Bureau of Indian Standards, to throw some light upon the setting standards in C&D waste management and their utilization.
Respected dignitaries present here, experts, my colleagues, friends. For the last couple of hours, we have seen such a good presentations on the process and manufacturing of the C&D waste utilization. We have also seen two case studies from MP and as well as Ahmedabad and from Delhi also. So just taking the 3R principle, 1R out of it, that is the recyclable. So I'm going to little bit talk more about the recycled materials, recycled aggregates which are used in the concrete and construction. Because based on the discussions which has held just now, I can see that many of the experts who are sitting here, they are not aware about the standard specifications which are present on the aggregates, recycled aggregates, as well as the applications of recycled aggregates. So that I will highlight upon that one. So first I will highlight about what is the significance and what are the needs of the Indian standards before moving to the specifications. So first, through the standards, we want to promote, we want to enhance the product quality and the process efficiency by giving the very specific requirements of the particular products to meet the needs of the entire concrete and concrete structures. Second one, facilitate trade of the products across border, national boundaries as well as the international boundaries, because BIS is a participating member at the ISO platform also, and there we have so many national standards body, different countries, they are having different, so making one standard which are adopted by the other countries, so that will facilitate the trade of the products between such those countries basically. And standards, they act as a catalyst for innovation and the research and development works. Some specifications we put in the standards, and that becomes a basis for carrying out further research, further innovation studies for the academic institutions, for the research scholars, for the students of various academic bodies. Then it also helps in the implementation of government policies and programs. That I would, at the end of this presentation, I would just make a request for this standardization. Then making the building trust and market confidence among the industries, among the associations, among the consumers. And the last one, not the least, contributes the overall economy of the nation and development. Those who are not aware about the standardization, just little bit highlight that basically since standards are national standards, so it cannot be formulated by one person, two person or three person. It needs to be formulated by taking the cognizance, by taking the expertise, by taking the contribution from different stakeholders across the nation, across the country, even at the international experts also. So we have different national technical committees in BIS which are dealing with different subject areas, and they gives their suggestions, their feedback for providing reference. So one of the technical committees in Civil Engineering Department at BIS, it is the Cement and Concrete Sectional Committee, which is responsible for the formulation and development of standards related to cement, pozzolanic materials, aggregates, concrete, and all the test methods which are required for testing and assessing the properties of aggregates, cement and concrete. A typical composition of the technical committees basically incorporates the government organizations, PSUs, academic institutions all across the nation, R&D bodies, industry associations, as well as the individual experts. Some of experts of our committee are already sitting here in this room. Okay, so now coming to the types of aggregates which are used in concrete. So first one is basically the natural aggregates, we all know, which come from the natural sources. And the second one is the aggregates from other than natural sources. If I'll go for the description of natural aggregates, it comes to the crushed stone, crushed gravel, uncrushed stones also, and aggregates which are formed by the natural disintegration of the rocks. which we are calling in this presentation virgin aggregates. Now, the aggregates which are coming from other than natural sources, they consist of industrial byproducts at the manufactured aggregates such as fly ash, bottom ash, iron slag and steel slag. And second one is the recycled aggregates from the construction and demolition waste. That is the topic for our discussion today. I will not go brief about the iron and steel slag because that will require entire one-day discussion over here. So today I will focus more upon the recycled aggregates as part of our discussion. So recycled aggregates from the C&D waste are further categorized. Every country they have their own standard specifications. As per Indian standard, we classify recycled aggregates into two categories. One is the recycled aggregates, one is the recycled concrete aggregates. So in recycled aggregates, we are having these aggregates have been derived by crushing of concrete, bricks, tiles, stones and many other masonry items which are present in the concrete construction. And it can be used as fine aggregates in the concrete. Then second, we are having the recycled concrete aggregates which are derived from the concrete after requisite processing, which we have seen in some of the presentations which are made earlier by our experts. And recycled concrete aggregates, they find usage as coarse as well as fine aggregates in the concrete. Now, if we make a comparison of the characteristics or performance of recycled aggregates as compared to natural aggregates, so we see that after making any demolition, we see the biggest villain in the recycled aggregate is basically the adhered mortar, or we call it as adhered cement paste basically. And that becomes the basis for all the differences in the properties of natural aggregates as well as the recycled aggregates. So first is basically the high porosity, which are found in generally all the recycled aggregates. Second one is the high water absorption because of the porosity, and because of this porous nature, it founds the lower specific gravity as compared to the natural aggregates. So all this machinery, all these innovations in the manufacturing, in the processing, they should take into account that as much as this adhered mortar, adhered cement paste will be removed from these aggregates, recycled aggregates, it will become much usable as if we will compare with the natural aggregates or virgin aggregates. So due to these above characteristics, utilization of recycled aggregates is limited in the concrete construction, and they are only, as of now, we are making only the partial replacement of the natural aggregates. But we can see that in further coming years, coming future period, we can see that more and more researches, more and more technological innovations and development will help us to increase further this partial replacement. Now coming to the first standard on the recycled aggregates as part of the C&D waste utilization. This is the basic, I will say this is basic parent and Bible code for the aggregates which are used in entire concrete and concrete construction. With all the products which are made of this concrete, it will be useful as a basic ingredient raw material to form that concrete. So this is 383 2016 specification coarse and fine aggregates for concrete. This standard permits the use of construction and demolition waste for the manufacture of aggregates as a step towards an effective management and utilization of this waste. So presently this standard is under revision. Last version, third revision came in 2016, and now very shortly we will come out with the next revision. What the changes we have, I just quickly brief about whatever the modifications we have made in this fourth revision. First one, of course, based upon the various innovations and developments in the technology as well as the material studies what have been done at National Council for Cement and Building Materials, various academic institutions of the country, R&D organizations, we have improved the extent of utilization of this recycled aggregates and the industrial byproducts aggregates in the concrete construction. That is the first major revision which has been made in this version. Second one, we have provided more rationalized requirements on the grading requirements of the aggregates, on the limits of deleterious materials, on the various extent of usage, different test parameters, right from the specific gravity, water absorption, and all those criteria which are there. So these are the limits for the recycled aggregates as per the existing IS 383/2016. Recycled coarse aggregate, as already mentioned, that it can be used in both coarse aggregate as well as fine aggregate. So in the earlier edition, it was restricted up to 25% in the plain concrete and 20% in reinforced concrete, which is allowed up to M25 grade only. And for lean concrete, all these recycled materials are completely acceptable. Lean concrete we generally prefer for M7.5, M10, up to M15 grade concrete basically. Now, the extent of utilization which are proposed as per the new revision draft of this 383. So we have improved these limits of percentage utilization in the coarse aggregate as 40%, in the plain concrete, reinforced concrete up to 40%. So these are the proposed values as of now. We have issued the draft for commenting, and we have got very good feedback from different stakeholders, and so we will again review these limits, and we will come back with the final recommendations as made by the concerned technical committee. Then another series in line with the IS 383. IS 383 provides the specifications or requirements which are required for producing any industrial byproduct aggregates or recycled concrete aggregates or recycled aggregates. Now, in order to test all those parameters, all those quality control parameters, there are list of test method standards which are there, which are covered under this IS 2386 series. So part 1 deals with the particle size and shape, which helps in doing the gradation. Part 2 deals with the estimation of deleterious materials and the organic impurities, which basically affects the durability property, mechanical properties of the aggregates, specific gravity, density, absorption, bulking. Then soundness, measuring mortar making properties of the aggregates. Alkali aggregate reactivity, which is very crucial and important for making the durable concrete structures, for improving the life of the structure. And part 8 deals with the petrographic examination. And since 383, the basic specification code is under revision, so in line with that, the committee has taken up this revision of this 2386 also. So both these revisions of 383 as well as 2386 will come together by early next year. Now coming to the specifications we have given for all the aggregates which are used in concrete construction. Now we are coming to the application areas where these are already there. So first one is the precast concrete paving grids and grass pavers. This is covered last year, it has been published 18894, which is already there. Then concrete paving blocks as per IS 15658/2021, it is there. Precast concrete paving flags 18889. Pulverized fuel ash cement bricks 16720, and yes, of course, not the least, concrete pavements as per the relevant IRC standards, and of course for the plain and reinforced concrete which we have seen in the last slides. So these are the applicable products which are there in the which are already governing in the various standard specifications. So it is my request that I will come to in the next slide for those areas. Then testing and quality control parameters, these are already listed in the 2386. Resistance to abrasion, crushing and impact, presence of fines, presence of chlorides and sulfates, alkali content, deleterious materials, and the durability requirement. These are the major revisions in the current IS 2386 basically. Now what are the way forwards to go in future? So first one is the regular updation and monitoring the requirements related to the recycled aggregates, for which BIS is always committed for any new proposal, for any suggestion in the revision or creating a new standard. So we are already working upon that one. Very shortly we are also going to release the new standard on the 3D printed concrete as well, which are also giving some guidelines about the recycled aggregates as well. Second, I will just want to further aid in doing the research and innovation studies which are already carrying out in the most of the academic institutions of the country, all the R&D bodies, that it should be carried out continuously in order to improve the properties of the recycled concrete aggregates, in what way we can further improve it, and secondly, what are the other new sustainable and alternate materials which can be used in making the concrete. So that is also a new suggestion, a topic for all the young engineers and scientists they can carry out for doing their researches in future. Then promoting the use of the sustainable and recycled materials to reduce the waste generation. This is already BIS is doing through their Indian standards specifications. And last but not the least, since I can see most of the government authorities and state government officials are sitting here, so I would request that whatever the specifications we have presented over here, coming to IS 383 or the various product standard specifications which are there, I would request that kindly go through these standards and try to incorporate them in the building bylaws or the tender documents on the various construction projects which are there, so as to make a suitable reference to the Indian standards. Because being the national standards body of India, we are always committed to create and formulate new standards and revisions of every existing standards, but we cannot enforce the agencies to use those standards until and unless they are referred by the government ministries as well as the concerned municipalities and municipal corporations. So that is my one of the request to all the officials who are sitting here to make reference to the these standard specifications. With this, I would like to thank everybody. Thank you, everyone.